So this is my first video on this channel, and I wanted to start with something that really interests me. That is, what would happen if our universe were made of 4 spatial dimensions instead of 3? The best way I've found to visualize 4-dimensional space is to use what I like to call downscaling. It may be a bit weird at first, but with enough practice it becomes fairly natural. Basically, the idea is to imagine what a 2-dimensional, or lower, creature would see if a 3-dimensional universe interacted with his. Let me give you an example. Say we want to imagine what would happen if a 4D hypersphere passed through our universe. Well, let's downscale it. Now we are imagining what would happen if a 3D sphere passed through a 2D universe. Only that slice of the sphere currently intersecting the 2D plane universe would actually interact with it. So as the sphere passed down through this universe, it would first create a rapidly growing circle, and then it would slow, and then shrink again until it disappeared completely, leaving the 2D flatlanders in complete awe. When we extrapolate this, we end up with the sphere appearing out of nowhere in our universe, which would then grow and then disappear again. If you had no clue about extra dimensions and you saw this happen, you probably would be a bit confused too. Another interesting property of 4D space is the fact that we can move in extra directions, so not just the up, down, left, right, forward, back that we have now, there's 2 extra directions that we can move in. This would pose some problems if someone were to all of a sudden gain access to extra dimensions. If we go back to our Flatlander universe, we can easily see why. Imagine our little Flatlanders just built themselves a bank. One day, Bill, a somewhat mischievous triangle, figures out some method of moving up and down as opposed to the forward, back, left, and right that he could do before. With this extra amount of mobility, Bill is perfectly capable of flying upward over the infinitesimally short wall of the bank's safe, going back down, stealing all of the money, and escaping again. So yeah, problems. If a 4-dimensional creature, let's call him Jake, decided to stop by our universe, he could do some pretty incredible stuff. From our perspective, he could disappear and reappear at will, pass through walls, and morph into seemingly impossible shapes. We already know how he did the first two, but how does Jake morph like that? If you've ever seen a CAT scan, you know what I'm talking about. When a doctor is looking through a brain scan, he can't see all of the brain at once because, well, it's opaque, so he has to look at it in slices. Without an understanding of what a brain looks like, you might just think the doctor was looking at some weird morphing image. It's the same thing. As Jake moves through our universe, we can only see one 3D slice of him at one time, so it may appear that his shape is changing and morphing. It's really the same thing as with the sphere, but the sphere is just a much simpler shape. Which reminds me, the most often cited 4-dimensional shape is actually one you may have heard of, the Tesseract. Tesseracts are referenced in the Marvel Universe, mostly in the Avengers, but are also seen in other movies like Interstellar. Sorry to ruin your superhero fantasies though, but that's not a Tesseract at all. Hollywood likes to use it because it has a cool name and is actually a mathematical thing, but really all a Tesseract is a 4-dimensional hypercube. Basically, a Tesseract is to a cube what a cube is to a square. Not quite as epic. What would a Tesseract look like though? When you try to downscale this, all we get is a cube, which isn't that helpful. Or is it? If we downscale again, and then again, and then again, we begin to see some patterns emerging that might help us. Starting with a cube, we can observe a few things. First, it has 6 sides. Each side is a 2-dimensional square. If we look at one of these squares, we can see that it has 4 sides. Each side is a 1-dimensional line. Downscale again, and we get a line. A line has, well, no sides exactly, but it does have endpoints, 2 of them to be exact. Finally, we downscale to a point which really actually has no sides. Okay, so each time we scale up, it gains 2 sides, right? So the Tesseract has 8 sides. Doesn't that just make it an octahedron? Ah, but you have to remember that each time, the definition of a side changed. The side was always of 1 less dimension than the figure as a whole. So the Tesseract would be made up of 8 cubes, or cells, as they're called. So I think that'll about do it for this video. I may make a part 2 sometime in the future, so keep an eye out for that. Hopefully this gave you at least a taste of the amazingness of extra-dimensional space, though. I'll be making more sciencey videos on this channel at some point, but until then, see you next time.